Good afternoon all. Today I fancy connecting two of these supercapacitors, 2.5 volts, 700 farads, in series, which just means putting a little bridging link across there. These are the two that I now have red indicator LEDs on, so I can see when the discharge circuit, which is a overcharge protection circuit, when that actually switches on. I'm assuming that when I charge these two in series that these two lights will come on at different times, so one will start protecting itself before the other. That'll be fun to watch. I also want to experiment with the technique for sticking these together. So what I'm going to do is put a little link wire in there with probably elastic bands around here, and then once the link wire's in, I'll lay these down, and I'm thinking of just tipping hot glue down in this gap and along the back as well, so that these two are permanently locked together. I'm hoping the hot glue won't melt this coating too much, and that there'll be quite a rigid connection between them. So let's start with the little wire link, and I'll get some elastic bands. So I get these elastic bands free from the postman. He just drops them on the steps outside. So I keep them. Got to have a little stock of elastic bands. That's probably not very tight, but it'd be good enough just to hold those two together while I bridge across that. And for that little bridging link, I'm going to use these short lengths of diode offcuts. What those are the offcuts from these. These are Shockley diodes 90 SQ035, which I was using as the external anti-backfeed diode in my solar charge controller. While I was manufacturing them, I just couldn't bring myself to throw these away, and they're actually quite useful for things. Actually, generally what I use them for is little bridging links between the 2-pin terminal on these 2.1mm connectors and my various power supplies. They're very good for making those little short bridging links. Quite a lot of these are stuck together because these are ones that suffered from the glue on the bandolier. These paper bands had gone all gooey, and there is sort of gluey residue stuck on the end of all of these, or most of them actually. Some of them aren't gluey, so I'll pick out the non-gluey ones and cut it down and use it as a little link. So I've bent these up at an angle because that was useful for connecting my power supply for charging them, this thing here. So I'll probably stick with that. There's no sense bending them back flat again. And I'll bend this at an angle because then I can just drop it in between those two. So let's put it approximately in the middle. Bend it at nearly 90 degrees, probably go for about 75 degrees or something like that. Right, now to try and put it down between these two capacitors. It's perhaps a little too long, and I perhaps haven't quite bent it. Yeah, I think it's a little too long and I haven't quite bent the angle enough, so let's take it back out and I'll just cut it a little bit shorter. So that's that side down. Yike. Okay, so that's a little bit shorter. Let's try and put that between them, and then I'll just solder it in situ. Still not quite at the right angle, but I think it's going to work. All I want really is that it's connected and that these two capacitors are at the same height. Oh yeah, that's interesting. We've got a sort of mechanical gain there, and it's shooting backwards and forwards between the two sides. That's complicated. How do I cope with that? Well, that looks about right. Let's get these really quite well aligned. Probably just sitting down on the bench. Get the soldering iron on there and get soldering. So I don't reckon that my little Antex is going to do this very well, so I've put the temperature controlled soldering iron on. This one is the Katsu. I've set it to 380 because I want it nice and hot. This is one that Adam Welch very kindly gave me, so thanks Adam. And let's get soldering. Yeah, it's definitely struggling with these solder fork terminals. which are clamped down by the big bolts on the capacitors. Right, bit of flux and we're good. So now what I want to do is put some hot glue down here. So I should be able to remove these elastic bands, get the hot glue gun set up. These are sort of holding each other together on that connection, but as long as I hold the bottoms together when I tip the hot glue in, should be able to glue these together. Right, my glue gun feels pretty warm, so let's run a bit of glue down the middle there and try and attach these two things together. It's going to set pretty quickly because of course there's a large expanse of metal under the plastic. I'm just wondering how the hot glue will impact on the plastic. Probably not much because these things don't go very hot. I think the glue is only about 70 or 80 degrees C. So I'll let that set and then I'll flip it over and do the other side. Right, that's probably had time to set, so I don't really need the elastic band now because this is pretty much a solid lump. So let's just run some hot glue on this side. Hot glue is probably a bit hotter now actually. Good, excellent. Right, now I get to charge two of these things in series. So I'm going to have to bend my diodes out a bit to fit the wider span of the connections now. Right, so previously I was limiting this to 3 volts, but voltage limiting this doesn't make a lot of sense. Really what I want to do is current limit it. This is now a 5 volt capacitor. We're probably going to lose about half a volt in the 2 diodes. So I need to set this to at least 6. I'll probably go for about 7 volts on here. Let's switch this on. So let's take that up to about 7 volts. And I'm going to go for, well, let's start at half an amp, and then if that takes too long, I'll up it to 1 amp. So that's half an amp. So let's load save, let's switch on. So that's half an amp flowing in. Let's just monitor the voltage on there, if I can get it to sit on voltage. Okay, 3.05 volts. So we're looking for probably about 6 volts on there, so that we've got 5 volts across the capacitors, and then we should expect to see these 2 LEDs come on. Now while this is charging, I'm going to set up a couple of voltmeters so that I can actually see the voltage on both the capacitors. I'll have to rearrange things a bit so that we can see the screens of the voltmeters. Right, positive to positive, which will be there. Negative here to negative on this one, so that's common. Now I need the middle one to link to these 2 posts, so I'm going to need 2 more wires. Right, now one of the LEDs came on, the left one, so I've wound the current down and that left one's coming on again. Don't know whether you can see that, it's just starting to come on. It's getting brighter and brighter. Right, I need the midpoint here to go to one of these meters, common on this one. Let's turn that around. So I've got a voltage on there now, 2.49, so that's at 2.5. And the light has come on. That midpoint, I don't think I can really get to that, so I'll strap one across to here. Yes, that's correct, isn't it? So let's put that on there. Oh, that one's much lower, 1.9. So now, hopefully, we should have that protection circuit offset the current that's flowing into that capacitor. So this voltage shouldn't climb too much above 2.5. Well, this one continues to climb and should reach 2.5 at some time in the future, and we should be able to get the 2 voltages matched. So let's just see where this one goes and where this one goes over time. Right, this one's up to 2.52. Now, at half an amp, of course, the voltage on the second capacitor is rising quite slowly, so let's increase that a bit to, say, I don't know, 720 milliamps. The voltage on this capacitor will now rise slightly because this protection circuit doesn't kind of work very digitally, it kind of comes in gradually. So at the higher current it will allow this capacitor to rise up to a slightly higher voltage, but I'm not too concerned about that small amount. This one now is climbing up a bit quicker, But yeah, I'm just waiting for this one to catch up with this one, hoping that this will sit, not climb too far above 2.5 volts. This LED is quite nice and bright now. Let's just zoom in on that a bit. Now, is that one starting to light up? No, I don't think it is. I think that's just a reflection off the cathode or anode leg, whichever leg it is that the light's reflecting off. Is that starting to light up now? No, shouldn't do at 2.0 volts. Right, let's keep watching them. So am I going to have a problem with these capacitors when they discharge, if you leave them for a few days and they discharge at very different rates? Am I going to have a problem that some will drop quite low like this one and some will hold their voltage a bit higher, so that the first charge has to be a low current charge in order that I don't overwhelm the protection circuit? That's now up to 2.54 volts. Yeah, so does the first charge have to be a low current charge, and then subsequent charges can be higher current? These things discharge internally quite quickly, so maybe this will happen every time. So perhaps that's going to limit. I mean, really, the thing about capacitors is how quickly you can charge them, but maybe you can't, because they become so unbalanced, and then if the protection circuit can't discharge a lot of current without allowing the capacitor's voltage to climb a bit too high, maybe you can never charge the capacitor bank very quickly. I don't know. This is all interesting stuff. So I've just taken this back down to 500 milliamps just to try and bring the voltage on this left-hand capacitor down ever so slightly, while still allowing the right-hand capacitor to still raise its voltage to go up. So this is coming down, is it? 2.536. It's coming. If it is coming down, it's coming down very, very slowly. This one's still going up. 2.2. Yeah, so I mean that circuit is, yeah, 2.535. So that is edging down ever so slightly with this lower current flowing through the two capacitors in series. So hopefully that won't now climb above 2.53. Not too unhappy with it sitting there, and still waiting for that one to get up to 2.5. Now, of course, it's just occurred to me that this is the one where I fitted the LED on the live stream. It does work, that LED. It always did work. I just didn't put enough current through it to make it come on the live stream. And of course, that was only a day or two ago. This one I haven't used for quite a while, so that probably explains why they've become so unbalanced. So perhaps I'm not too concerned because they haven't been used sort of sitting next to each other. Perhaps when they get balanced, they will stay a bit more balanced, and then I can put a higher current through them when charging them up. Yeah, perhaps that will be a bit more satisfactory. Right, just hit 2.5 volts on the right hand capacitor, and I can see that the right hand LED is just starting to come on. Let's see if I can just show that. It's rather hard to see because there's a lot of reflected light, but yeah, that one has just come on. So let's watch that one brighten up as the voltages sort of come into balance. Right, well, they're absolutely in balance voltage wise. That's assuming my 2 meters are set to the same voltage. I can't remember whether they were. I didn't think they were quite, but yeah, they're very closely balanced. But the LEDs are very different in brightness. I seem to remember that one didn't come on very bright when I first fitted it, so I think that LED came from a different batch. So I might change that one to see if I can get them to be about the same brightness. But yeah, those are balanced up nicely. Now, if I turn this power supply off, I'd expect to see these voltages fall away at a similar rate, and I'd expect to see these two LEDs go off sort of concurrently. Let's watch that fall away. I'll just pause for a moment. Now this one's fallen faster. Is that because it hasn't had a sort of soak charge? I know that's not supposed to be how capacitors work, but it does seem to have fallen away more quickly. This one, of course, had been sitting at 2.5 volts for quite a while. This one had only just got there. The LEDs are both very dim. That one I think's gone out, but that one's dimmer anyway. This one's just about to go out. But anyway, yes, those two are now connected together. I think what I'm going to do is discharge these caps perhaps put a bulb across the two caps, take the two protection boards off, change that LED, and then come back and have another look at this. But yeah, for the moment, that's all I wanted to achieve. Two capacitors in series. I can charge them in series, and I can watch the two voltages. That's good enough for today. And just a quick update, I changed that LED and they're now both equal brightness. We've got nice equally matched voltages across the two capacitors, so the protection circuits are obviously quite well balanced. The brightnesses of the LEDs are the same. I've just wound this down to 300 milliamps so that the voltages came down a little bit, but yeah, everything's nice and evenly matched, so that's looking pretty good for a pair of supercapacitors in series. And from a slightly different angle, yeah, nicely matched, these two LEDs now. Cheerio.